The new artificial gravity environment system. Phase 1. The first step would be to add an additional module to the International Space Station. For the purpose of this video, we will call it Threshold. Phase 2. Next, 2 additional payloads of roughly equal mass will be attached to Threshold, each by 3 tethers. The first, which we will call Habitation 1, would be directly facing the Earth. The other, the AGE or artificial gravity environment, would face away from the Earth. With a gentle push, either by rockets or even by mechanical means, these 2 payloads would be launched in opposite directions, still tethered to Threshold. At a certain point, these payloads will begin to accelerate. Habitation 1 will begin to accelerate when the force of gravity pulling downwards exceeds the centrifugal force caused by circling the Earth. The AGE module will also begin to accelerate, this time when the centrifugal force of circling the Earth surpasses the force of gravity downwards. When these opposing forces become great enough, the system will stabilize in alignment with the Earth. The tethers will run straight from the AGE module through Threshold to Habitation 1 and point straight toward Earth. Now we can bring the tethers to a gentle halt. We now have simulated gravity on the AGE module and very real, though reduced, gravity on Habitation 1. These are relatively weak forces, however, and we want forces sufficient to maintain the astronauts' health. Phase 3. An additional habitation module is brought to the space station, Habitation 2. It is attached to the 3 tethers leading to Habitation 1 with motors. We can't just ferry Habitation 2 down to Habitation 1. The additional mass would throw the system out of balance and drag the International Space Station out of orbit. However, we don't have to add mass to the AGE module. Instead, we can allow the tethers to the AGE module to extend further as we lower Habitation 2 to Habitation 1. The longer tethers to the AGE module will further exaggerate the difference between the centrifugal and gravitational forces. This will allow the upward or outward force on the AGE module to balance the additional downward or inward force the mass of 2 habitation modules causes. Finally, we add a third habitation module, Habitation 3. We deploy it in nearly the same manner, once again extending the tethers to the AGE module to balance our forces. Now the tethers to the AGE module are long enough for the centrifugal forces to so outweigh the force of gravity that significant artificial gravity is achieved. Phase 4. Until this point, it was unnecessary to differentiate between the tethers, but now, for simplicity, we will. The tethers to the AGE module will be called AGE tethers 1, 2, and 3, with AGE tether 1 closest to the station and AGE tether 3 furthest. Likewise, the tethers to the habitation modules will be called Habitat tether 1, 2, and 3, again with Habitat tether 1 closest to the station and Habitat tether 3 furthest. A final payload is brought to the station, consisting of 2 elevators and 2 counterweights. The first elevator will be attached to AGE tether 1 and AGE tether 2. It will ferry astronauts to the AGE module. The second elevator will be attached to Habitat tethers 1 and 2 and will ferry astronauts to the habitation modules. One counterweight, the smaller of the 2, will be attached to AGE tether 3. The larger counterweight will be attached to Habitat tether 3. We are now ready for normal operations. Phase 5. Normal operations. The astronauts are eager to explore their new home, but the elevator holds just 1. As the first astronaut rides the elevator down to the habitation modules on Habitat tethers 1 and 2, notice that the counterweight on AGE tether 3 moves out towards the AGE module. As the elevator returns to threshold, it is empty, and so the counterweight has to move less to maintain balance. As one astronaut after another shuttles to the habitation modules, the counterweight on age tether 3 moves further and further away. Now the habitat elevator returns to threshold with an occupant. This astronaut will be the first to use the age module. She enters the age elevator, and as she begins to ascend, the counterweight on habitat tether 3 begins to move towards the habitation modules. Both counterweights are computer controlled, of course, which maintains constant balance in the system. It is important to note that neither the habitation modules nor the age module are dock-worthy platforms. The instantaneous addition of significant mass to either of these would throw the whole system out of balance. This would drag the International Space Station out of orbit, either down to Earth or into the depths of space. This does not necessarily mean you cannot launch from them. Consider the following admittedly romanticized scenario. Space has long been compared to the oceans. Who doesn't like tales of mermaids saving sailors from the watery depths? Assume you have an additional module attached to the habitation modules with a corresponding ballast mass on the age module. Let's call it the Medical Emergency Re-Entry Module, or MERMAID for short. Should an astronaut be injured or become ill, they could use the MERMAID to return to Earth without disrupting the system's balance, as long as the ballast above was ejected simultaneously. While this will hopefully remain a fictitious scenario, it demonstrates some of the flexibility of this system. Please understand that this was not a simulation. It was a rough graphical depiction to foster understanding.